Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi Herman and Corin. So we know that in the world of computers there are three main operating systems for desktop and for laptop devices. We have Linux and all its many distros, and you guys know I'm a very long-term Linux user, so that's where I live. Computer speaking, at least on my servers, Raspberry Pi even is the furthest I've ventured outside of that. I use a VM to do anything I really need to do on Windows, and contrary to the myth that Linux users hate Windows, I've actually got no problem using Windows. My wife has a Windows laptop and I quite like it actually, but I just prefer the flexibility of Linux, and it really, I think with AI agents it's never been easier to not get bogged down in the complexity of the OS, because you can do so much with an agent. That's my tip anyway. Cloud Code is superb for systems administration, and it can run anything it can do on Bash. It can basically take control of your OS, and it makes administering a Linux system, keeping it up to date, keeping it secure, debugging it vastly easier. It's been a total game changer. Anyway, something I've always wondered, Herman and Corn, we know that Linux has a fairly niche market in the desktop world, despite the yearly articles asking whether this will be the year of Linux. It's never quite been the year of the Linux desktop, and I have to be honest, I don't think it ever will be. I don't think that there's just that much appeal to most computer users. Most folks want something that just gets the job done. But it remains the dominant choice on servers, whether we're talking about plain Ubuntu or Debian or vendor spins on Linux like AWS Linux, but basically Linux is the dominant OS in the server world. So we see kind of an inversion of what we see on desktop, where most people run Windows and Linux is niche, and in the server world there is a Windows server, but it's comparatively niche, or that's always been my understanding. I'd love to understand, Herman and Corn, besides the reasons of complication, the technical reasons why different OSs are best suited to different jobs, because I've heard that one of the major advantages of Windows that makes it more suitable on the edge or on phones and laptops and desktops is that its ability to compute parallel tasks is better than Linux, whereas a server you might think of traditionally as running one processor workload repetitively. I don't know if that still holds true, but I'd love to understand that from a computational standpoint, what the strengths and weaknesses of both of these are for those two different uses. And then of course we have to talk about Mac, the third option. And Mac I've always thought was kind of adjacent to Linux, but I have to be honest, Herman and Corin, for all the time I've spent using Linux, I've never really bothered to actually go deep into the difference between Unix, Linux, and all of that. So Herman and Corin, I'd love to talk about the fundamental architectural differences, not just the security, how the operating systems rank from a security standpoint, because that's another topic in itself. Let's talk today about just how these different operating systems are best and worst suited to different environments. And finally, let's talk about the really small stuff, the IoT devices and the SBCs like Raspberry Pi, where we have these very small computers running at the edge. And what we see is basically lightweight, ultra lightweight things built around the Linux kernel. I don't recall ever seeing a Windows Raspberry Pi. I'm sure someone's made one and you can probably run something on ARM64, but it's pretty niche. So Herman and Corin, let's chat about that in today's My Weird Prompts.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I am joined as always by my brother, the man who probably has more open terminal windows than he has childhood memories.
Herman Poppleberry here, and I will have you know that my childhood memories are very well organized in a series of nested directories, though I will admit my uptime is currently much better than my sleep schedule. I recently hit 300 days of uptime on my main workstation, which is a personal record, though my wife says it is a cry for help.
300 days? Herman, I am pretty sure that is a fire hazard, or at least a very lonely way to live. But hey, hopefully your kernel doesn't panic today, because we have a deep one. Today's prompt comes from Daniel, and it is a doozy. He's asking about the fundamental architectural differences between Linux, Windows, and macOS. He wants to know why each one dominates its specific niche, whether it is servers, desktops, or tiny edge devices like the Raspberry Pi.
This is a classic, but it is also a moving target. The landscape of February 2026 is quite different from even 5 years ago. Daniel specifically asked about some perceived strengths, like Windows being better at parallel tasks on the edge, while Linux excels at repetitive server workloads. We definitely need to deconstruct that, because the reality is a bit more nuanced than just one is for servers and one is for games. We are also looking at a world where AI agents are now the primary users of these operating systems in many enterprise environments.
Right. And he also touched on the architectural relationships between Unix, Linux, and macOS. I think that is the best place to start. People often lump them together, especially the not Windows group, but they have very different family trees, don't they?
They really do. If we were looking at a genealogy chart, macOS and Linux would look like cousins who share a very influential grandfather named Unix. Unix was developed at Bell Labs in the late 1960s and early 1970s by legends like Ken Thompson and Dennis Ritchie. It introduced concepts we take for granted today, like a hierarchical file system, the idea of everything is a file, and a powerful command line shell.
And macOS is actually a direct descendant, right? It is not just Unix-like, it is certified Unix.
Exactly. macOS is built on a foundation called Darwin, which is open source, believe it or not. Darwin is based on the Berkeley Software Distribution, or BSD, which was a major branch of the original Unix tree. When Steve Jobs returned to Apple in the late 90s, he brought the Next Step operating system with him, which was built on the Mach microkernel and BSD, that evolved into macOS. So, when you open a terminal in macOS, you are interacting with a system that has a direct, certified lineage back to the original Unix standards. It is why a lot of old-school sysadmins feel right at home on a Mac.
Whereas Linux is the rebel cousin who wasn't actually born into the family, but learned all the family traditions and improved on them.
That is a great way to put it. Linus Torvalds wrote the Linux kernel from scratch in 1991. He was a student in Finland and wanted a Unix-like system that could run on his personal computer because the commercial Unix versions were incredibly expensive and Minix, which was a teaching tool, was too limited. Linux is technically Unix-like. It follows the POSIX standards, which stands for Portable Operating System Interface. This means that code written for a Unix system can usually be compiled and run on Linux with very little effort. But under the hood, the Linux kernel is its own beast entirely. It was designed to be modular from day one.
And then we have Windows, which is basically the neighbor who built a completely different house, but eventually added a Linux subsystem, Sunroom, just to be friendly.
Windows is the outlier. While the early versions of Windows were shells running on top of MS-DOS, the modern Windows architecture, known as Windows NT or New Technology, was a clean sheet design led by Dave Cutler. He actually came from Digital Equipment Corporation where he worked on VMS, so Windows NT has more in common architecturally with high-end mainframe operating systems than it does with Unix. It uses a completely different way of handling processes, threads, and memory. It doesn't use the everything is a file philosophy. Instead, Windows is very object-oriented. Everything is an object with a handle.
So, if they are so different under the hood, why did they end up in these specific silos? Daniel asked why Linux is the king of servers and IoT, while Windows remains the desktop standard. Is it just momentum, or is there a technical why behind it?
It is a mix of both, but the technical why is fascinating. Let's look at the kernel architecture first. Linux uses what we call a monolithic kernel. This means the entire operating system, including device drivers, file systems, and memory management, runs in the same privileged memory space, which we call kernel mode or ring 0. Now, that sounds like a recipe for a crash, right? If a driver fails, the whole system could go down.
Right, that's the classic blue screen fear. But Linux is known for being incredibly stable. How does it manage that with a monolithic design?
It manages it through rigorous peer review and a very modular design. Even though it's monolithic, it uses loadable kernel modules. You can add or remove drivers and features on the fly without rebooting. This modularity is a huge reason why it wins in IoT and servers. If you are building a smart light bulb or a high-altitude drone, you don't need a printer driver, a Bluetooth stack, or a graphical interface. You can strip the Linux kernel down to its bare essentials, making it tiny and incredibly efficient. In 2026, we have micro distros that are less than 10 megabytes but can still run a full web server.
And Windows? I've heard it described as a hybrid kernel.
Yes, Windows NT is a hybrid. It was originally designed to be a microkernel where the core kernel is tiny and everything else runs in user space for safety. But that was too slow for the hardware of the 90s because passing messages between user space and kernel space has a high performance cost. So they moved a lot of stuff back into the kernel for performance. The Windows architecture is very heavy by design. It carries a lot of legacy compatibility and a very complex subsystem for handling the graphical user interface. You can't really strip down Windows the same way you can Linux. Even Windows Server Core, which is headless, is still quite large compared to a minimal Linux install because it expects a certain level of subsystem availability.
That makes sense for the server side, where efficiency and uptime are everything. But Daniel asked a specific question about parallel tasks on edge devices. He mentioned that Windows might be better at handling parallel tasks, while Linux excels at repetitive workloads. Is there any truth to that?
That is a really interesting observation, and I think it stems from how each OS handles multitasking. In the world of operating systems, we talk about the scheduler. This is the part of the kernel that decides which process gets to use the CPU and for how long.
I'm guessing the Windows scheduler and the Linux scheduler have very different priorities.
They do. The Windows scheduler is optimized for what we call interactive responsiveness. It wants the user to feel like the computer is fast. If you move your mouse or click a button, the scheduler gives that thread a priority boost. It uses something called quantums, which are small slices of time. Windows is very aggressive about preempting lower priority tasks to make sure the UI doesn't lag. It is designed to handle a lot of disparate, unpredictable tasks happening at once in a way that feels smooth to a human. That's why it feels better at parallel tasks on a desktop. It's juggling your browser, your music, your word processor, and your system updates, and it's making sure none of them stutter.
Whereas the Linux scheduler is like a focused worker who just wants to get the job done as fast as possible.
Exactly. The default Linux scheduler, called the Completely Fair Scheduler, or CFS, is optimized for throughput. It wants to make sure every process gets its fair share of the CPU so the total amount of work done is maximized. This is perfect for a server. If you are a web server handling 10,000 requests a second, you don't care about responsiveness in the sense of a mouse click. You care about processing those requests efficiently. However, Daniel's point about Windows being better at parallel tasks on the edge might be referring to how Windows handles asynchronous I/O. Windows has a very mature system called I/O completion ports, which is excellent for handling thousands of simultaneous connections.
But didn't Linux catch up there? I remember you talking about something called I/O urring.
Great memory, Corn. Yes, Linux introduced I/O urring free a few years back, and by 2026 it has become the gold standard. It allows Linux to handle asynchronous I/O with almost zero overhead. So, while Windows had a head start in parallelism for certain types of edge applications, Linux has largely closed that gap. The reason people might still perceive Windows as better for parallel tasks on the edge is often related to how it handles complex hardware abstraction. If your edge device has a bunch of proprietary sensors and a complex GPU, the Windows driver model might make it easier to manage those parallel data streams than a custom Linux build.
So, Linux wins on the extreme low end, like the Raspberry Pi, and the extreme high end, like supercomputers. And Windows holds the middle ground of the general-purpose desktop.
Right. And for IoT and edge devices, the repetitive workload, part Daniel mentioned, is actually a strength. If an edge device is just monitoring a sensor and sending data to the cloud, Linux can do that with almost zero overhead. It can sit there for years without a reboot. Windows, because of its complexity and its update model, is much harder to maintain in those set it and forget it environments.
Let's talk about that update model for a second, because that feels like a huge architectural difference. On Linux, I can update the kernel, the drivers, and all my applications without even stopping my work, usually. Windows, well, we've all seen the working on updates. Do not turn off your computer. Screen at the worst possible moment.
That is a fundamental difference in how they handle file locking. Windows, by default, locks files that are in use. You can't replace a system file while the system is using it. So, Windows has to stage those updates and then apply them during a reboot when the files aren't locked. Linux doesn't lock files in the same way. You can replace a binary on disk while it's running. The running process keeps its reference to the old version in memory, and the next time you start the program, it loads the new version. This is a massive advantage for servers where you want 99.999% uptime. In fact, with live patching, we can even update the Linux kernel itself without a reboot.
I want to circle back to macOS for a second. We've established it's Unix, but it's also the dominant choice for creative professionals and, increasingly, developers. Where does it fit in this server versus desktop divide?
macOS is the best of both worlds for a lot of people. Because it's Unix, it has all the powerful command line tools that developers love. You can run the same scripts on your Mac that you run on your Linux server. But because Apple controls the hardware and the software, they built a graphical interface and a set of frameworks that are incredibly polished and responsive. In 2026, with the M4 and M5 chips, the integration between the macOS kernel and the silicon is tighter than ever. They have dedicated accelerators in the hardware that the kernel can talk to directly for things like AI processing and video encoding.
It's like the Windows interactive responsiveness, but with the Linux-like architectural foundation.
Precisely. And Apple's kernel, XNU, which stands for X is not Unix, is a very sophisticated hybrid. It uses the Mach microkernel for things like memory management and inter-process communication, and then it has a BSD layer on top for the file system and networking. It's designed specifically for high-end consumer hardware. It handles Grand Central Dispatch, which is Apple's way of managing parallel tasks across multiple cores, incredibly well. It is arguably the best in the business at power management, which is why MacBooks have such incredible battery life compared to most Windows or Linux laptops.
But you don't see macOS on servers or tiny IoT devices. Why is that?
Licensing and hardware coupling. You can only legally run macOS on Apple hardware. Apple doesn't make a Raspberry Pi style board, and they don't make rack mount servers anymore. Even if they did, the macOS kernel is not designed to be stripped down. It's a heavy OS, just like Windows, because it carries all the frameworks for the graphical interface, the animations, the security layers, and the ecosystem integrations like iCloud. You couldn't run macOS on a device with 64 megabytes of RAM. It would just laugh at you and refuse to boot.
Which brings us to the Raspberry Pi and the ultra-lightweight Linux kernels Daniel asked about. Why is Linux the only real choice there? I mean, I know there is a version of Windows for IoT, but you almost never see it.
Windows IoT Core exists, but it's very limited and it's not Windows in the way people think. It's more of a platform for running universal Windows platform apps. The reason Linux dominates the Raspberry Pi and similar single-board computers is twofold: architecture and community.
Architecture first?
Right. Linux was one of the first operating systems to be ported to almost every CPU architecture imaginable. Whether it's the x86 chips in our desktops, the ARM chips in our phones and Raspberry Pis, or even old PowerPC or MIPS chips, Linux has a version for it. Because the kernel is open source, if a new chip comes out, the manufacturer or the community can write the code to make Linux run on it. Microsoft is much more protective. While they have a version of Windows for ARM, it's mostly targeted at high-end laptops, not tiny hobbyist boards.
And then there's the lightweight aspect.
Exactly. When you are working with a Raspberry Pi, especially the smaller models like the Pi 02W, you might only have 512 megabytes of RAM. A standard Windows install would eat that just by existing. But with Linux, you can use something like the Yocto project or Buildroot to create a custom distro that only contains exactly what you need. You can have a fully functional Linux system that boots in 2 seconds and uses only 20 megabytes of memory. This is what we call embedded Linux.
That's incredible. So you're basically building a bespoke operating system for every device.
In the professional IoT world, yes. For a hobbyist on a Raspberry Pi, they'll usually use Raspberry Pi OS, which is based on Debian. It's a full desktop OS, but even that is much lighter than Windows. But if you're building, say, a smart thermostat or a connected industrial sensor, you're using a tool like BusyBox.
I've heard that name. What is BusyBox?
It's often called the Swiss Army knife of embedded Linux. It combines tiny versions of many common Unix utilities, like CELZ, CPE, HOS, TPEELZ, TPELZ, TBEELZ, TBE, WIFE, 9TE, HOS. So instead of having hundreds of separate files, you just have one. This saves a massive amount of space on the storage chip. It's these kinds of optimizations that make Linux the only viable choice for the billions of smart devices out there.
So, to summarize the why for Daniel, Windows wins the desktop because its architecture is optimized for human interaction, and it has decades of legacy software support. Linux wins the server and IoT world because it's modular. It can be stripped down to nothing. It's incredibly efficient at high throughput tasks, and it runs on anything.
And macOS sits in that sweet spot for people who want the Unix power with a premium consumer experience, even if it's locked to one ecosystem. But there is one more thing Daniel mentioned that we haven't touched on, the environment. Specifically, why Windows stays the standard for laptops and desktops despite all these Linux advantages.
2 words, driver support. This is the hidden architecture, right?
Exactly. Because Windows has 90% of the desktop market, every hardware manufacturer, whether they make printers, webcams, or high-end graphics cards, writes their drivers for Windows first. These drivers are often closed-source blobs that the manufacturer provides. In Windows, these drivers run in a specific framework called the Windows Driver Foundation, which is designed to keep a buggy driver from taking down the whole system, though it doesn't always work.
And Linux is at the mercy of the community to reverse engineer those drivers, or wait for the manufacturer to release a Linux version.
Exactly. While the Linux kernel actually has more drivers built in than Windows does, meaning you can often plug in an old printer and it just works on Linux without downloading anything. The very latest, cutting-edge hardware often struggles on Linux for the first few months. For a gamer who just bought the latest NVID, IA card, or a professional who needs a specific piece of medical imaging hardware to work perfectly on day one, Windows is the only choice.
It's a bit of a chicken and egg problem. People use Windows because the drivers are there, and the drivers are there because people use Windows.
Precisely. And Microsoft is very good at maintaining what we call BIS, or binary interface stability. You can take a program written for Windows 95, and there is a very good chance it will still run on Windows 11, or the new Windows 12. The Linux world doesn't care as much about that. They prefer source stability. They'll say, just recompile the code for the new version. That works for open source software, but it's a nightmare for a company that sold a piece of proprietary software 20 years ago and doesn't want to rewrite it.
So, Linux is a living, breathing, constantly evolving organism, while Windows is like a city that keeps building new skyscrapers but refuses to tear down the old foundations.
That is an excellent analogy. The Windows Foundation is full of shims and compatibility layers. If you look at the Windows source code, it's full of if statements that say, if this program is SimCity 2000, then do this weird thing with memory because the original programmers took a shortcut. Microsoft has a dedicated team whose entire job is making sure old apps don't break. That level of dedication to backward compatibility is why businesses stay on Windows. If you're a bank and your core software was written in 1998, you aren't moving to Linux unless you absolutely have to.
Okay, so we've covered the desktop, the server, the IoT world, and the family tree. Let's look at the future. Daniel's prompt mentioned AI agents and how they are changing things. He said he uses Claude Code for system administration on Linux. How does the rise of AI change this architectural battle?
This is where it gets really interesting for 2026. For a long time, the barrier to using Linux was the complexity. You had to know the command line, you had to understand the file system, and you had to be comfortable editing config files in a text editor. But if an AI agent like Claude or a local LLM can do that for you, that barrier disappears.
Right. If I can just tell my computer, hey, set up a web server with a firewall and automatic backups, and the AI knows exactly which bash commands to run, then the user friendliness of Windows becomes less of a factor.
Exactly. In fact, Linux is actually better for AI agents than Windows is. Why? Because Linux is fundamentally text-based. Everything is a file, and everything can be controlled via a string of text in a terminal. AI models are incredibly good at processing and generating text. It is much easier for an AI to navigate a Linux file system and edit a config file than it is for it to navigate a complex Windows GUI with nested menus and dialog boxes. We're seeing a shift where Linux is becoming more accessible not because it's getting simpler, but because our tools for interacting with it are getting smarter.
Does that mean the year of the Linux desktop might finally happen? But not because of a new version of Ubuntu, but because of AI?
I still think the driver and legacy software issues are too big for a mass migration for the average person. But for developers and power users, absolutely. We're already seeing it with WSL, the Windows subsystem for Linux. Microsoft realized they couldn't beat Linux in the developer space, so they just put a Linux kernel inside Windows.
That's the sunroom I mentioned earlier. It's such a weird hybrid. You're running a Windows kernel, which is running a lightweight virtual machine, which is running a true Linux kernel.
It's incredibly meta, but it works. It gives you the Windows driver support and UI with the Linux development environment. For a lot of people, that's the ultimate architectural compromise. But it also highlights why Linux is so dominant. Even Microsoft had to include it to keep their OS relevant for developers.
I think we should also address the security side of the architecture, as Daniel mentioned that too. There's this long-standing belief that Linux is more secure than Windows. Is that built into the architecture, or is it just because Windows is a bigger target?
It's both. Architecturally, the Unix-style permission system, where every file has an owner and a group, is very simple and robust. Linux was designed from the ground up as a multi-user system where you don't run as the root or administrator by default. Windows, in the early days, was a single-user system where you had total control. Microsoft has been trying to bolt security onto that ever since.
And that's where those annoying pop-ups come from?
Right. User Account Control, or UAC, was an attempt to bring that Linux-style security to Windows. But the biggest difference is the attack surface. Windows has so many legacy components and complex AP is that there are just more places for a hacker to find a hole. Linux is more transparent. Because the source code is open, security researchers can find and fix bugs much faster. However, in 2026, Windows has made huge strides with things like Microsoft Pluton and TPM 2.0 integration, which provide hardware-level security.
I'm curious about your thoughts on the repetitive workloads versus parallel tasks on edge devices again. If you were building a drone, for example, which needs to handle sensor data, flight stabilization, and maybe some AI vision all at once that's very parallel, would you use Linux?
For a drone, you actually move away from general-purpose operating systems like Linux or Windows and into the world of RTOS or real-time operating systems.
Ah, a fourth contender.
Yes, an RTOS like FreeRTOS or Zephyr is architecturally different because it guarantees determinism. In Linux or Windows, if the CPU gets busy, a task might take 10 milliseconds one time and 50 milliseconds the next. For a drone, if the stabilized flight task takes 40 milliseconds too long, the drone crashes.
So even Linux isn't fast or steady, enough for some edge tasks.
Not the standard kernel, no. There is a real-time patch for Linux called preempt_RT that tries to make it more deterministic, but for truly critical tasks, you want a tiny specialized kernel that does one thing perfectly. This is another reason why Linux is so great. You can use it as the brain for the high-level tasks like AI vision and have it talk to a smaller RTOS chip that handles the actual flight motors.
It's all about picking the right tool for the right level of the stack.
Exactly. There is no perfect operating system. There is only the best architecture for the specific constraints you have, whether those constraints are power, memory, legacy software, or the need for a pretty interface. And in 2026, those lines are blurring. We have Linux running inside Windows, we have Windows apps running on Linux via Wine and Proton, and we have macOS running on custom silicon that looks more like a phone chip than a computer chip.
I think one thing people miss in this discussion is the concept of user mode versus kernel mode. We've talked about the kernel, but how these systems interact with the user's apps is also a big part of the stability and performance difference, right?
Oh, absolutely. This is one of the most important concepts in modern computing. To protect a system, the CPU has different privilege levels. The kernel runs in the most privileged level called kernel mode. It has direct access to the hardware. Your apps, like your browser or your games, run in user mode. They have to ask the kernel for permission to do anything, like writing to a file or sending data over the network.
And the way they ask is through system calls.
Right. Now, in Linux, system calls are relatively cheap in terms of performance. The transition from user mode to kernel mode is very fast. In Windows, historically, system calls have been more expensive. This is partly because Windows does a lot more checking and has a more complex security model for every single call. This is one reason why Linux can feel faster for things like file operations or network-heavy tasks. It's like Linux is a warehouse where the workers can just grab what they need, while Windows is a high-security vault where you have to show your ID every time you want a pencil.
That's a bit of an exaggeration, but the principle holds. Windows has gotten much better at this, but the architectural baggage is still there. On the flip side, that high-security vault approach is why Windows has such a robust system for things like group policy, which allows IT administrators to control every tiny detail of thousands of computers in a corporate environment. Linux has tools for this, like Ansible or Puppet, but they aren't as integrated or turnkey as the Windows Active Directory ecosystem.
And that's why you see Windows in every office building. It's not just about the OS on the laptop, it's about the management layer that sits on top of it. Linux is a collection of parts that you can assemble into a masterpiece, but Windows is a pre-built machine that comes with a service contract and a remote control for the boss.
Well, Herman, I think we've thoroughly deconstructed the why behind our digital world. It's amazing how much of our lives depends on decisions made by guys in the 70s and 80s.
It really is. Every time you tap your phone or check a website, you are benefiting from 50 years of architectural evolution. It's a beautiful, messy, incredibly complex tower of code. And as we move further into the age of AI, that tower is only going to get taller and more automated.
And if you're enjoying our deep dives into that tower of code, we would really appreciate it if you could leave us a review on your podcast app or on Spotify. It helps other curious minds find the show.
It really does. And if you have a weird prompt of your own, or if you want to tell me why my take on the Windows scheduler is totally wrong, you can get in touch with us at show@myweirdprompts.com. I promise I read every email, even if I don't always have the uptime to reply immediately.
You can find all our past episodes and a contact form at myweirdprompts.com. We're on Spotify, Apple Podcasts, and pretty much everywhere else you get your audio.
Thanks to Daniel for sending this one in. It's always fun to get back to the basics of how these machines actually think. It reminds me why I fell in love with computers in the first place, even if they do keep me up at night.
This has been My Weird Prompts. Thanks for listening, and we'll see you in the next one.
Goodbye, everyone. Keep your kernels stable and your quantums long.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.